Hey guys, today we're going to be working on basic factoring, or factoring trinomials with an a value equal to 1. So we have 3 practice problems up here we're going to go over in this video. If you want to try these on your own, go ahead and pause the video, try these out, and then come back and we'll go over step by step how to solve each one. Okay, before we get started, let's go over a couple of things. First off, I have standard form for polynomials written right up here so that we can see where A, B, and C are, because those are some terms that I'm going to be using consistently throughout the video. Second, we have our criteria for when we can use basic factoring here. It must be a trinomial with an x squared x constant format or some variable in that same order of exponents. And then our a value, the coefficient before the x squared, must equal 1, or there can't be a visible coefficient there, right? Finally, we have our rule when factoring these, that we need factors of c that add up to b. You may be like, where's that rule come in? Well, we're going to get there. Let's start one of these problems, though. So number 1 says x squared plus 13x plus 36. Does it fit all of our rules of factoring? It does. Coefficient of 1, and it has the variable order in our trinomial that we're looking for. So always remember the first step in basic factoring is simply to write 2 binomials that begin with x. This is going to be the basis for our solution to the problem. We just have to figure out what numbers go with them. That's when our rule comes in, factors of c that add up to b. Well, let's see. Factors of c. In problem 1, what is c? It's our constant, 36. What are some factors of 36 that add up to b? What would b be here? 13. So let's think. Factors of 36. We have 36 and 1. We have 18 and 2. We have 12 and 3, 9 and 4. Which one of those would add up to 13? Exactly, 9 and 4. When you add those 2 factors together, you get 13. When you multiply these 2 numbers together, you get 36. So they meet both of the criteria for us to use them in our binomial. Since it is a positive 9 and a positive 4, we're going to go ahead and write those in on our binomials, x plus 9, x plus 4, and we have our answer. We're done with that problem. Simple as that. Let's take a look at number 2. Number 2 says x to the third plus 9x plus 20. Does that meet our criteria? Well, it has an a value equal to 1, but wait, something's off with it, isn't it? This is x to the third, and then x, and then 20. What's wrong with that? We can't use this type of factoring on a polynomial that doesn't have the configuration squared to the first constant. This isn't going to work. So the fact of the matter is, it's not necessarily that this isn't factorable. There may be some other method that can be used to factor it, but it is not able to be factored using our current method of factoring. So for the time being, there's no solution right there. We can't do that one. We'll go ahead and move on to number 3. Number 3 says x squared minus 4x minus 12. You'll notice this meets our criteria as well. X squared, x constant, and we have a coefficient of 1 in front of the x squared, or an a value of 1. So we want to go ahead and write our 2 binomials, both starting with x, or whatever variable is used in the polynomial you're working with. If you have a polynomial that says r squared and r and constant, then they would each start with r, that kind of thing. So we want to find factors of c. C here is negative 12. Always remember it has to keep the sign with it. So factors of negative 12 that are going to add to equal b negative 4. So now here's kind of an interesting thing. Whenever we're looking for factors that multiply to make something and add to make something else, if we're looking for a positive number here, then you always just want to look for the sum of them. Like up here, we look for which one of these has the sum of 13, because we're trying to make that positive number. But other times, whenever we're looking for a negative number, maybe we're looking for what two numbers have a difference of that. That's just one way to think about it. You don't always have to look about it that way, but that's one thing that helps me a little bit. So let's go ahead and look at some factors of 12. We'll think about what it means for this 12 to be negative in a moment. But factors of 12 are going to be 1 and 12, 2 and 6, and then 3 and 4. Now we know since it's a negative 12 that they're factors of, one of these numbers is going to be negative. In each of those pairs, one has to be negative. But whenever I was talking about finding which one has a difference of 4, which pair of numbers are 4 apart, that's the one I use to help me identify which set of factors it's going to be, and then I'll determine which one's negative. Sorry if I didn't explain that too well in the beginning. So whenever I look at this, I notice that 2 and 6 are 4 apart. So those are probably going to be my factors. Now what I have to do is figure out, is the 2 going to be negative or is the 6 going to be negative? Well, since this says they have to add together to make a negative 4, then the larger number is going to have to be negative. So we would have a negative 6. Positive 2 plus negative 6 or minus 6 is going to get us a negative 4. All right, so I'm going to go ahead and write that in here. 2 and negative 6, those are my factors. And then I'll get to write those in my binomials. A positive 2 and a negative 6. So we get the binomials x plus 2, x minus 6 as the factors, or the factored form, of x squared minus 4x minus 12. If you have any questions about this or would like to see other specific examples of this type of factoring, feel free to drop a comment below. I'll get back to you as soon as I can. Otherwise, thanks for watching.